Hello, my name is Harsh Pratap Singh. I'm from Lucknow, currently enrolled in my high school. So today I'm going to teach a very important aptitude topic, that is time, speed, and distance. So this topic is not just important for placement, but it also important for real life problem solving. So the best part of the topic is, if our basics are clear, we can solve even tougher questions very easily. So I've made a presentation slide on it. I will share my screen, show you the slide. So I hope my screen is visible. So today's topic is time, speed, and distance. So this topic is all about understanding the three relationship between three things: how far you can travel, that is distance; how fast you can travel, that is speed; how long it takes, that is time. So all these three are interconnected, and almost every question in this topic is based on this their relationship. So why do we need to learn this topic? Why this topic is important? Before learning, let's understand it. So first, it's frequently asked in placement test. Companies often include these questions because they test your logic and speed. Secondly, it is also common in competitive exams like SSC, banking, and railways. And third, it has a strong real life application. It's not just theory, it's something we use in daily life. Like when we order food, we track how fast it will come to us. So now I would explain some basic definitions. So there are three main terms. First is speed. So speed means how fast an object is moving, for example 60 km/h. So the next is distance. Distance is total path covered, for example like 100 km, 120 km. So the time is the duration taken to travel that distance, for example 2 hours. So if we know any two values, we can easily find the third value. So this is the foundation of this entire topic. If we know any two values, we can definitely find the third value. So now I'm going to teach this with the help of analogy. So we will take the food delivery examples. So imagine you ordered food from a restaurant. So distance is distance between restaurant and your home, and time is delivery time, and speed is delivery boy's speed. Now think, if the delivery person is very fast, your food will get very quickly. If he's slow, then you have to wait more longer. So the key ideas is, the more the speed, less the time, and the less the speed, more the time. So this is a simple relationship, and that is base of all the questions from this chapter. So yes. So there are three basic formulas: speed equal to distance upon time, distance equal to speed into time, and time equal to distance upon speed, as you can see on the screen. So there is no extra formulas. In exams, question may look difficult, but they always come from these formulas only. So we don't have to just memorize it. Should understand when to apply which formula. And here I've shown some quick tricks you can follow, some basic formulas, and some basic unit conversion. And for the relative speed, if the same direction, then we have to subtract speed. If in relative speed, if the two objects are moving the opposite direction, then we have to add the speed. And for the equal distance or average, we use this formula mentioned below. And I've also showed the relationship between speed and time, and also the ratio. So now let's talk about the concept understanding and unit conversion. So the time is basically measured in hours or seconds. Distance is measured in meters or kilometers. Speed is measured in kilometer per hour or meter per second. So important conversion is 1 kilometer per hour equal to 5 by 18 of meter per second, and 1 meter per second is 18 by 5 kilometer per hour. So shortcut is we multiply, if we want meter per second, 1 kilometer, we multiply it by 5 by 18. So many students make mistake here. So we have to be very careful about the units. Now, for the concept understanding, this is a very important concept. So we know that speed and time are inversely related. So if the speed increases, the time decreases. And if the speed decreases, the time increases. And the simple line you go, like we have to remember, if faster you go, less time it will take. It's very basic, right? So now I will talk about a basic example. Like if a car travels 60 kilometers in 2 hours, so we basically want to find the speed. So speed equal to distance upon time. So distance is 60 kilometers divided by 2 hours, so 30 kilometers per hour. So very simple. Just apply formula and get the answer. Now for the conversion, we have to convert 72 kilometer per hour into meter per second. And I've already mentioned the trick. We have to multiply by 5 by 18. So you answer will be 20 meter per second. So conversion trick is very important as it saves time. So now I will talk about the real life applications of this. So this concept, that is speed, distance, and time, is used everywhere. Google Maps uses it to show estimated time. Delivery apps predict delivery using this. Train schedules, sports performance. So this is a very practical topic. Like in cricket also, speed of the ball is measured through this concept only. Now I have one practice question. If a person travels 150 kilometers and 50 kilometers per hour, so this so time taken. So for this, we need to find time equal to distance upon speed. So we'll divide the distance and the speed and we'll get the time, that is 3 hours. Now there are some important interrelated topics to this. First is relative speed. So relative speed is the when two object moves, it can move in two directions, that is same and opposite. If the direction is same, we have to subtract the speed. If the direction is opposite, we have to add the speed. So it is relative speed is used in trains overtaking problems. So for the average speed, we often get confused. Average speed is not just we find the average of speed. Average speed is total distance traveled upon total time taken. It is not as a simple speed average. So we always have to calculate total distance and total time. For the third, the train and boats problem. So for the train problem, distance is the length of train. So if two trains, distance equal to sum of length. And for the boat generally moves in two streams, upstream and the downstream. So upstream, that is we have minus boat speed minus stream. For downstream, we have to plus boat plus stream's length. So these are not a new concept. This is just our applications of the basic formulas we've learned just earlier. So in conclusion, I would like to say that it is very simple. It has only three formulas. It is very scoring topic, but concept clarity is very important. Practice is must. So we just don't have to memorize it. We have to understand it practically. So now I would explain bonus question. So this is a trick question. So half distance, if a person cover half distance at 40 kilometers per hour and half distance at 60 kilometers per hour, what is the average speed? So most of the student do error in this problem. They simply add the average speed divided by 2 and get the answer 50. But it is totally wrong. Why? Because I explained you earlier. Average speed is not just average speed, we find the average of speed. Average speed is total distance traveled upon total time taken. So assuming in this problem, let's take the distance 120 kilometers. And for 120 kilometers, we go 40 kilometer per hour. For that, we divide and we find out the time, that is 1.5 hour. And for the next half, 60 kilometers hour, we divide again with the distance 60 kilometers, that is 1 hour. So total time is 2.5 hours. We don't have to divide it by 2 hours only. It is we have to divide it by 2.5 hours. So the average will be 120 divided by 2.5. So that is 48 kilometer per hour. So the key learning in this is never take simple average. Now, uh, I would like to say at the end that thank you everyone for listening. I hope I was able to make you understand the topic and the concept clearly. If we, the best thing about this topic is if we practice regularly, this topic is very easy to score. So yes, thank you so much for listening to my presentation. Thank you so much.